In this video, which is the 8th in my series on how to write a 3D space shooter game in Unity, I'm going to be adding collision avoidance to our AI-controlled ships. I'm going to be using raycast to determine if we're about to hit something, and then applying the appropriate yaw or pitch to avoid those collisions. So get your favorite beverage, pull up a chair, and follow along as I teach you how to write a 3D space shooter game in Unity. So in order to add collision avoidance, let's go into our prefab, and we're going to look at our AIShipMovementControls, and we're going to go and take a look at the prefab for this actually. And what we're going to want to do is we're going to add a new empty game object to this. And I'm going to call this collision avoidance. And by the way, I changed the setting so that it will always create these at world origin, which is nice. So let's go back into our script. And we're going to create a new class here. And I'm going to move that to its own file. Add that to source control. And let's go back into the editor. And what we're going to want to do, so this guy is going to be on the ship that it's controlling. And what we're going to do is we're going to add a few points where we can raycast from to check to see if we're colliding with anything. So if we take and expand this, what we're going to do is we're going to add a new empty object, and we're going to call this probe top, and I'm going to move it up. That looks pretty good. And we're going to duplicate this, and we're going to call it probe bottom, and I'm going to move it down below here. That's probably pretty good. And now we're going to want to create a right and a left probe. Let's try probe left. That looks pretty good. Yeah, I think that looks pretty good. And we will duplicate that. We will call this probe right. And we will move this to the right, like so. And I want to create two more probe left and rights to go kind of in the middle. So I'm going to duplicate these. I'm going to call this probe left inner and probe right and inner. And let's see, probe right inner, we're going to move in. Something like that. Maybe a little farther out. And then that's at 3.06, so we'll make this negative 3.06. There, so we've got some probes that we can raycast from just sticking out of our ship there. And they are on this collision avoidance object. Okay. Now let's go into our script. Actually, we need to add our script to it. We'll go into that script and let's add our serialized fields. So we're going to want a couple of transforms here. This will be our top probe and our bottom probe. And then we're going to have a collection of transforms for our left probes and right probes. And we're going to have a serialized field, a float, and this will be our detection range. And then we'll add a serialized field to display our rays. That's just for debugging purposes. And we'll default that to false. All right, and we're going to have some constants here, some integers. We're going to have avoid left equal -1. Avoid up equals -1. Avoid, actually, I think I want this to be +1. Avoid right will be -1. And avoid down will be -1. Actually, that will be 1. And no avoidance will be 0. And we need an equal sign here. Okay. And I'll add a public bool on collision course equals vertical avoidance, and I'll create this property in a minute, is not equal to no avoidance, or horizontal avoidance is not equal to no avoidance. And now some properties here. We will have a public integer property, vertical avoidance, which will have a public getter and a private setter, and a horizontal avoidance, which will have a public getter and a private setter. All right, we're going to want to cache our transform like always. And then I want to add a couple of strings that I can see in the inspector to just tell what we might have collided with. So I'm going to add public string. Can I make those read only? No. Public string, we'll say vertical collision, horizontal collision. And these will show up in the inspector, and I will get rid of these after we have everything working. There we go. So this is a expression body method. It's basically a property that this is like shorthand for a getter. All right. In the awake method, we want to cache our transform. And in onEnable, we want to initialize vertical avoidance equals horizontal avoidance equals no avoidance. All right. Now, most of the work is going to be done in the update method. So I'm going to add a couple of methods here. I'm going to say vertical avoidance equals get vertical avoidance. So basically, I'm going to calculate the vertical avoidance and update. And then these properties can be called from other classes without recalculating whether or not we were avoiding something. And let's create method. I'm using Alt-Enter in Rider. Oops. Alt-Enter, create method. So I think that's the same keystroke in Visual Studio. If not, in Visual Studio, I think you can just right-click on it and say create method. All right, so what do I want to do in... Oh, I want to add a late update here to display our rays. If not, draw... What did I call it? Display rays. If not, display rays, return. Otherwise, we are going to do a debug draw ray from the top probe's position along the forward axis. Oops. We want to go times our detection range. And we'll use cyan. Why not? And we want to do the same thing for our bottom probe. We'll make this one yellow. And now for our left and right probes. So we will do a for each var left probe and left probes debug.drawRay left probe, daggone it, left probe dot position left probe, it's covering up my screen, probe dot forward times detection range color dot red. And then we'll do the same thing for our right probes. And let's do this green. All right. So right now I'm just going to return no avoidance. And let's go into our editor. And let's assign these components here. So top probe, bottom probe, probe left inner, probe right inner, detection range. I should give that a default in the script. Equals 100. All right. Come back out into the editor. Will that update? Display rays. Okay, so let's just turn on gizmos. Actually, they are on. So if we hit play, let's turn off our target that we're chasing here. And we'll actually set our target 1,000 units in front. All right. Hit play. And we should see our rays projecting out from our probes. All right, so let's take a look at this. We got our cyan one, our yellow one, our red ones. I don't see our green ones. Did I overlook something here? Probe right, enter. And they are in right probes. Oh, they actually, I made them gray. Maybe they were displaying and I just didn't see them. Yeah, there they are. So there are our probes projecting out from our ship, and they should tell us if we are going to collide with something on either side or above or below. So how do we do that? So what we want to do is in our get horizontal avoidance function, we want to iterate. I guess I'm doing vertical first here. We will iterate. Oh, since it's vertical, we only have a top and a bottom. So I will say we have to do a raycast. And I'm actually wondering, because of the speed at which the pitch is applied, I think, because what's going to happen here is if we're about to collide with something on the top, we're going to pitch down. But very quickly, we will no longer be on a collision course with it. So we'll just resume back toward our target. And we'll see a lot of dipping up and down, I think. So I think what I want to do, instead of doing a raycast, is maybe do a sphere cast. So let me go back into the editor. I want to see how wide, well, how big of a radius I need to give for that. So let me just add a sphere right here. 3D object, sphere. So that's radius 1. And so if we were to double that, I think that would work. So we would cast a ray from this point out at radius 2. And so we will keep thinking we're colliding until we're pointing down far enough that that radius ray will not collide with anything. So let me go back into our script. And we will here, we will do a sphere cast. We will say if physics.spherecast, we want to check our top probe. We'll give it a hit variable here to record what we hit with, and our detection range. I just spent all that time talking about the fact that I wanted to do a sphere cast and give it a radius of 2, and then I didn't actually put in the radius. All right, so if that hits something, let's assign what we hit to our string that we want to show in the inspector. And then we're going to return avoid down. All right, so we hit something with the top probe, so we want to avoid down. Let's check the bottom probe now. If physics.spherecast bottom probe dot position radius of 2 bottom probe forward a hit variable and detection range. right. We will set our vertical collision to be the name of that collider, and we will return avoid up. All right, that will give us our direction to avoid vertically. So now let's do the horizontal avoidance. And in this case, we need to loop through our probe. So var left probe and left probes. So we'll check the left side first. If in this case, I'm just going to do a raycast because I think that we apply yaw faster than we apply pitch. It just seems to take effect faster, so I don't think we're going to have the same issues. So let's see, physics.raycast. We will use right probe dot position. Oh, we're doing left. So left probe dot position, left probe dot forward, our hit variable, and our direction range, our detection range. So we hit something. Let's set our horizontal collision to be our hit collision.name and return avoid right. All right, so we hit something with our left probe. Let's avoid right. Now let's do our right probes. Because it's outside the scope. All right. So if we hit something with our right probe, we set the name, and we avoid left. All right. I think that's all I need for our collision avoidance. I have an error, it looks like. Let's see what we've got here. Do I have an error? I have two errors, apparently. There we go. All right, let's go back into the Unity editor and go into our movement controls. So we're going to want to add some things to our AIShipMovementControls. So again, I'm going to use these optional Odin inspectors. You do not want to add these if you don't have Odin. You will get compilation errors. Oh, and by the way, I realized something that I probably should pass on. If you're grabbing my code off GitHub and you grab like a later branch, like from part 2 or part 3 or part 4 or whatever, if you're just cloning that repo fresh, you're going to have issues because the prefabs in there will be broken because they're referencing assets that I had imported from the asset store, which I cannot distribute through my GitHub repo. So if you try to just clone one of those later branches and go from there, you're going to run into problems with broken prefabs. There's going to be missing meshes, missing materials. So you can pull that code down to look at it and see how it's coded, but don't expect to be able to build it and run it as it is. Really, you need to follow along from the first branch. I guess you could start from the beginning and then merge in the subsequent branches, and that would work. Anyway, I just wanted to pass that on. Little sidebar there. So we got our box group AI ship controls, and we're going to add a serialized field, and I'm going to add an inline editor. This is another optional Odin parameter, and the editor type will be fold out. I don't want that. I want inline editor object field modes to be fold out. And all of that to say I want to add a collision avoidance. Collision avoidance. All right, so let's just jump out to the Unity editor. We should, if we go up to our escort fighter here, under AI movement controls, we now have collision avoidance. And let's just drag that right in there. And you can see he's got his probes. He's got his detection range display rays is turned on. All right, so that's why I like the inline editor, because even though I'm on the escort fighter, I have that inline editor for that collision avoidance. I have the inline editor for the AI ship controls, the AI ship movement controls, and its children. So that's really nice. That's one of the reasons I really like Odin. If I didn't have that, I would have to actually just go down here and edit those settings here. Not a big deal. I just like having it all up there. And because I made it a fold out, I can just collapse that. And I don't see all that. All right, so what do we want to do with our collision avoidance? Let's go back into here. And I think I want to add some variables to store our horizontal avoidance and our vertical avoidance. Maybe I'll add them later. First of all, in update, yeah, I want to do all this stuff in update. So yeah, the first thing I'm going to do here is after we get our distance to target and calculate our local direction, I am going to check collision avoidance and Alt-Enter, create method. And I'm going to move that down to the bottom of the file underneath our other methods. So yeah, I'm going to add some variables. I just think it has simplified things. And I think I might do some other refactoring while I'm in here. Right now, the yaw amount and the pitch amount and stuff is calculated inside these functions, which are called by these public properties. I think I might want to go ahead and calculate all these in update, and then just return the calculated amount from up here. So let me go ahead and do that. While I'm in here, let's add another show and inspector attribute. This basically will allow private fields to be displayed in the inspector, and this is an Odin attribute, so don't add this if you don't have Odin. You can just make these public if you want. So I'll have yaw amount, pitch amount, roll amount, and thrust amount. And I'm reusing a variable that I already had declared right here. So I'm going to rename this one. I think it's RR, and I'm just going to rename this underscore thrust. Now I can add thrust amount without getting an error. Okay, that's nice. So in here, I will say yaw amount equals get yaw amount. Pitch amount equals get pitch amount. Roll amount equals get roll amount. And thrust amount equals get thrust amount. And then I will change these to return yaw amount, pitch amount, roll amount, and thrust amount. All right, so that fixes that. So now in check collision avoidance, we can actually set these appropriately. So I'm going to add a couple more variables then. We'll have horizontal avoidance. And they're going to be floats too, so I'm just going to add them here. Horizontal avoidance and vertical avoidance. And let's see. Get yaw amount. All right, so let's go down to check for collision avoidance. I'm going to split this up into two functions. Get or check for horizontal collision. Horizontal collision. Horizontal collision. All right. And check for vertical collision. All right, so in check for vertical collision, I'm going to say if mathf.approximately 0 collision avoidance dot vertical avoidance, then I'm just going to set vertical avoidance to be 0. Otherwise, vertical avoidance will be collision avoidance dot vertical avoidance. And in horizontal, if approximately 0 collision avoidance dot horizontal avoidance equals 0, else horizontal avoidance equals collision avoidance, horizontal avoidance. All right, so now in get yaw amount, we can say if not mathf approximately 0 horizontal avoidance, return horizontal avoidance. And for pitch, if not mathf dot approximately 0 vertical avoidance, return vertical avoidance. So what we're doing here is if our collision avoidance told us to avoid up or left or right, we're going to return that. And remember, that's a value. It's either -1 or 1. We're going to return that as our yaw amount. So we're either going to yaw left or right if we are avoiding left or right. Otherwise, we'll fall through into our normal calculation where we just pursue our target. And same thing for pitch. If we're avoiding up or down, we're going to return a pitch amount of -1 or 1. Otherwise, we're going to do our normal pursue our target. And roll gets set based on the value of pitch. So, or yaw, I'm sorry. So I think we're good. And of course, none of this affects thrust. So let's save this and go back into the Unity editor and see if everything compiled. And it did, but this is a weird error that I'm getting from the Odin inspector. It's a known bug. Hopefully they'll be fixing that soon. It doesn't seem to bother anything. It just throws up an annoying error message. So in order to test this, I mean, right now we should just start flying towards our escort fighter. And we shouldn't be avoiding any collisions. We're just flying forward toward that ship that's up there. So to test this, let's turn on our asteroid field. And let me reset the transform on that. And let's give ourselves a lot of asteroids to avoid. And we have it set up so I can switch to the camera that's following our chase ship. So just drop this down so I can see what's going on in here. Got these variables here. And let's just see what happens when I hit play and follow that ship. Let me move our fighter backwards so he's outside the asteroid field a little bit. There we are. Ooh, looks like he's heading towards an asteroid. And he avoided it. Oh, that's so sweet. That's really, really tough. Let's reduce the diameter of the asteroid field. Pack them into a smaller area. This should be interesting. Ooh, we hit one. He hit another one. I think there was a problem with our horizontal avoidance, maybe. So the vertical avoidance is working pretty good. I wonder if the roll is messing it up too. Yeah, I wonder if maybe I don't want to roll if we're doing avoidance, although that looked pretty good there. Okay, let's see. That's just amazing. Let's pack them in a little bit tighter. It's like a solid wall of asteroids. Well, he didn't quite get through without hitting them. It might have not be possible with them packed in that tight. I'm going to disable roll when you're avoiding collisions. I think I can do that. So basically, I want to go into here and get roll amount. I will say if not math approximately 0, vertical avoidance, or not math approximately 0, horizontal avoidance, return 0. This way we should not try to apply roll if we're avoiding a collision. I don't know if that'll make a difference or not. I just want to see what it looks like. Although it did look pretty cool watching them roll around. And there's our massive wall of asteroids. Yeah, we definitely have an issue when they're that far apart. When he's making that hard of a turn. And it looks like it's a vertical thing. It gets that weird shaking going on. Well, he's definitely flying around them, looking for a way around. Let's make that asteroid field a little less dense again. Let's change our target to be a cube. We'll disable that fighter. Stop. And let's see, go in here and create a cube. We will call it target. We'll put it 1,000 units out. We will go into our escort fighter. And for target, we will drag that in. Looks like we have some debugging to do there. It's not really easy to maneuver that target in such a way that it changes the direction of the ship. I mean, it seems pretty good. It's not perfect. See if we can keep an eye on these guys here and these guys. So we're currently avoiding a vertical collision with a rock. But it's interesting, these values are 0. We're definitely seeing us avoiding both vertical and horizontal collision here. I should say what side we're avoiding it to, is what we're colliding with it. On the right, left, bottom, top. That looked nice. Okay, one thing I want to do is if I have a collision, I want to say left probe.name plus hit or detect it or let's go ahead and do this. All right. All right. All right, let's keep an eye on these. I want to take a look at this. That's interesting. I detected something and then collided with it. So this probe top detected this rock. We were yawing, looks like yawing right and pitching up. Or maybe yawing left and pitching up. We can also turn our gizmos on in the play window here. All right. So it looks like our left probe should be colliding. So the top probe detected the same rock as the left probe. So we should avoid down and right. It almost looked right. It is working. Yep. So I think that's working pretty well. The real test will come when we start doing dogfighting and flying through the asteroids. And actually, the real test will come if we have the asteroids damage the ship when they collide with them. And we can see how well an enemy AI-controlled ship can do against a player ship in a dogfight through asteroids. All right, well, I think that about wraps it up for this video. I think we made a good start on implementing the AI collision avoidance into our AI ship control movement. Hopefully you found that interesting. And if you did, do me a favor and click that like and subscribe button. It really does help me out a lot to grow my channel and to support content like this. And I want to be able to continue to make videos like this and get them out there for the Unity developers to enjoy. And if you have any questions or suggestions about anything that you've seen here or things that you'd like to see, be sure to drop a comment and I'll do my best to get back to you as soon as I can. So thanks so much for watching and good luck on your game development journey.